Hi everyone. Uh, Let me introduce myself. Myself Adi Moolam Chandra. Also call me Adi. I have around 8 years of experience in GCP and DevOps. I had worked with various other DevOps tools, and with GCP, I was working for uh, deploying of code as well as BigQuery, and I had come across various other activities. And I work for financial domain of IT. And then before my career in IT, I worked as a assistant professor in an esteemed engineering college. Later on, I had moved my career into IT. As a whole, I have 17 years of experience, where I have around 10 plus years of experience in IT. Apart from that, I have in teaching. I had my MTech in computer science, BTech in computer science. With respect to my qualifications, I was about to complete my PhD in computer science. So, and coming to the, am I audible? Could you, one of you please confirm?
Yes, sir.
Yeah, I'll go then. So, that's about me. Let us go with today's demo session. Uh, Let me share my screen. Let me know once you are able to see my screen.
Yes, sir.
Yeah, thank you. So, uh, all others can share your details on the chat such that I can know what are your what are your, who are you like that. So, what is your need? I hope we can go through the syllabus today, and we can have a we will have we will have practical sessions from tomorrow onwards. So now let us go with this demo. Okay, fine. So please share your details in the chat such that I can know all of you later. Yeah. So need not to share your personal details. Just share your name and your present roles. That's enough for me. Yeah. Yeah. Coming to today's session. In today's market, the leading requirement is infrastructure. The infrastructure is nothing but providing everything from a single location to everyone. So without occupying the geographical locations, without, I can say, purchasing something as a whole, most of the resources are shared by the devices or the users. When I look at such a thing is possible using computer networks. As a basic definition of computer networks, a computer network is nothing but a collection of computers, or even a collection of interconnected autonomous computers. A computer network is simply defined as a collection of interconnected autonomous computers. The word autonomous is very much important here. The reason is a computer which is capable of computing individually is meant by autonomous, not a thin client or some other thing which will just display what the server shows. Apart from that, and a collection of autonomous computers. When we go to thin clients and other things, those are all distributed networks. So we need not to worry on that. We will be having here something that works over a computer network. So the cloud is an enablement for providing a glue to run a necessary system and providing majority of the requirements of an organization via as a service. As a service. Let us look the structure of an organization. An organization, when we see, let us say you own an XYZ company or you are working in an XYZ company. So in that organization, you need to recruit resources and you need to provide machines for them, in the sense laptops or desktops, that what we simply call it as infrastructure. Apart from that, to for those machines, we need data centers, we need network, and we need many other things that what we need for execution of that particular or for delivery of that particular organization. If the organization delivers products, if the organization provides service, whatever it is, the organization need lots of data centers, lots of network, and it need to purchase various software, and it need to purchase the IDEs and as well as the server machines. These things, to avoid these things, the cloud computing had provided a solution. The cloud computing provides everything as a service. Yes, you have a machine and it is connected to network, let us say internet. That's enough. Your data center will be ready. Your server machine will be ready, which will be serving the needs of your n number of employees. They will be working on various nodes, or I can say, or systems, and the data will be stored in a common location, which you need not to maintain. That what we call it as an environment where a native application can be stored. Your code can be stored, where your uh, day-to-day activities are recorded. Everything will be recorded when something is provided as a service by another organization, ABC. So an ABC is an organization that provides you the infrastructure. So cloud is such a tool where we will be where it will be providing infrastructure as a service. Yes, there can be another organization which will be providing you rich class of libraries that allows you to execute your applications that you built on using your integrated development environment, which is also provided integrated development environment with rich class of libraries that allows you to execute in a runtime environment as a container we are providing. So that we call it as platform as a service. For an integrated IDE, for an IDE integrated development environment, we need to select a language or we need few other softwares which you need to install and you need to manage by in your own organization. Need not to worry. Such software can also be provided as part of cloud. So a cloud is an environment in which which it will provide SaaS, PaaS, and IaaS. What we call it as software as a service, platform as a service, and infrastructure as a service. Okay. And the front end, you will see software and IDE and infrastructure comes in the back end. However, this we need not to worry. It will be provided by another organization, which the users or the resources in your organization, resources, human resources, I say, will be using this facility and do the task. So this is what we will see, where we are not purchasing the product. It is something like purchasing a software, a product is costly, and you need to maintain, and maintenance is your risk. All these things, instead of purchasing and maintaining and upgrading versions, and whenever the product is outdated, you need to buy a new product. All these things you need not to worry. All these things are shared via the network in your organization. Such an enablement is a cloud. Okay. There are a number of organizations. There are n number of organizations these days, I can say. Out of these, the major players of the industry are Amazon Web Services, GCP Cloud. GCP stands for Google Cloud Platform, and Azure. Azure is Microsoft's one. What are being provided as cloud services by these organizations, and what are their local names? A service that is being provided by an organization, by an AWS, let us say, that will be called with a different name in AWS. Let us say, come to the virtual server. Virtual server. This is a more interesting thing. This is more interesting thing. If you are already working with an organization, then you might have been seen this. But if someone is learning it for the first time, let me explain this concept. Earlier, might be in your graduation, you might have been came across two things. One is hardware and software. For a naive graduate who is coming for the first time, so he might be seeing like a hardware is something that you touch, and a software that's something that you use on that hardware. Without that hardware, you cannot use that software, and you cannot touch, or you can use it, but you can see it, but you cannot touch it or something. These are all the definitions that what we will see with respect to software and hardware. So now a virtual server is that provides a virtual hardware for your operating system to run on. A virtual server, you can select your required hardware. For example, if you want to purchase a machine, a computer, you will be looking into the configuration of the computer. So the configuration, let us say you need 16 GB memory, 1 TB storage, and uh, i7 latest generation processor. All these things, is what we call it as configuration. So when we look into the configuration, you will purchase a machine with all these things. Yes, if you have a machine, you are selecting all these things, and they are all physical. They are all physical. Now, in a cloud environment, you can select the configuration of your requirement. So you can select the memory just using a drop down. You can select your CPU. You can just on a text field, you can simply order for the storage, say 100 GB or 100 TB if you want. There is no limit. You can just ask, and it will be provided for you, and you can start using that particular server, and those machines are pre-installed machines. Pre-installed machines. Just select your operating system, that will be ready for you in minutes, in just over seconds. That is the advantage of cloud. So the services that are provided by the cloud are not only virtual service. You can see what platform it is going to provide, and how it will be providing serverless computing. It will be providing Dockers for maintaining the code. It will be providing Kubernetes objects for storage. So a storage location. And when I say an object storage, it is something like an operational data, and an archive data is something that what you store in, and you will be using it for less number of times, and it is a huge storage. And I hope you are aware that a storage, when it goes huge, we will be moving on to we will be moving it onto the other location where we will be have huge size, and it will be uh, less what I can say, less expensive, and then an operational storage is a, a bit expensive when compared to archive storage and data warehouse, where we will be storing large amount of data, and such things will be stored onto the tapes, such that it will be uh, a cheaper, I can say a cheaper storage when compared to operational, archive, and data warehouse. So these kind of different storage mechanisms. So if you need an operational data that which is used daily in your organization, such things we will be storing in object storage. Once you have worked on it completely, you want to move it. So you can move it for archive storage for some where it will be stored onto this, and your operational storage, what I can say, the object storage, will be provided for you. And then coming to the rest of the things, you can see like content delivery and managed data warehouse. So these are all the various things that what we will look in, and then various organizations will provide them with different names, but more or less the features will be same. But however, talking to the particular nomenclature of that particular usage, and being a specialized uh, engineer in that particular for that particular usage of the tools that is provided by that organization is important. So we can say an AWS DevOps engineer, or a GCP DevOps engineer, or an Azure engineer, or whomever it is. So talking to that particular nomenclature is quite important. Okay. And our prime focus is on GCP. Uh, we are not going much into AWS and as well as Azure. Our prime focus is on GCP. So there are, apart from the organization who are all rivals for GCP, AWS and Microsoft Azure, GCP is a public cloud provider, and most of the Google's resources are kept free, and for organizations it is offered as pay per use. Okay, so pay per use, if you use it, pay. Otherwise if you're not using it, it will be offered to you, and it will not be charged. GCP offers a comprehensive set of computing services, everything for management of data to web, and delivery of videos via internet, and it is also capable of having artificial intelligence and ML, machine learning capabilities. For using all these things, what are all the requirements? It is very simple. If you have a Gmail ID, credit card, and a phone number, you can just start using your GCP, your Google Cloud. So using a Google Cloud is such simple. And now let us understand how a software is being developed. Okay. So before going to this, let us recap what we have gone through earlier. So whether it is a demo session or whatever it is, I feel happy if you have any doubts and if you interrupt me in between. Um, if you have anything, please don't hesitate. Please don't hesitate. You can ask me at any time. Let me recap. So I had started with the definition of computer networks, basics of cloud, and various cloud providing organizations, and what is GCP and what are the requirements for accessing Google Cloud. So is all that okay? Shall we move ahead from introduction to another topic?
Sure.
Yeah, thank you. So please don't hesitate to ask. So you can always interrupt me in between if you are there. Otherwise, you can go through the recordings. We will have a channel for clearing doubts for you. We will be coming through the channel for clearing doubts. But a live interaction will always fetch us more, because even though in a channel, I might be busy, I will be looking into the channel at only periodic times, but not always. So, but however, it will be solved in a time, but it takes time. But in a live interaction is more beneficial. Yeah. So, software development life cycle. So, if you had your graduations in computer science, most of you had seen this from software engineering Roger Pressman. Roger Pressman was one of the persons who considered as a the who taught this particular software development life cycle, and most of them had picked it for the same life cycle, and it has been the only development model that is available for for long period of time for long period of time. So in an organization, let us say a customer arrives to you, but this is a old model. This is no more in use. Only for understanding, I am giving you a brief about how the organizations are working or worked, I can say, in past. Yeah. So let us say a customer came, and the customer want to develop a product for his needs. No others will interact the during the analysis phase. Probably the product owner along with some manager will be attending a session with the customer, and he will give requirements, and we call it as requirements gathering. After collecting those requirements, there will be another set of team who will prepare SRS. So software requirements specifications. Then it comes, there it ends. That phase is ended. The another phase, the product comes to the another phase. Another phase is another team. Another phase is another team. In the team, again, for the requirements, on analysis of the requirements, a design is proposed by an architect or a set of designers, and then we will be looking for moving that particular design for design to development. You can see it is moving from one to other, one to other, one to other. In the development phase, there will be front-end developer, back-end developer, putting all together, they will develop. They will give it to you. So after development, it will come to the testing. It will comes to testing. During the testing phase, the bugs are identified and it will again goes to development. Sometimes the tester will report all these things, and then once the testing is passed, so there will be a slight interaction between these two teams. No, however, the teams will be interacting on those things, but definitely it is something like moving from one phase to the other phase. So developers feel my job is done. Only if there is an issue, I will be I will be talking to this. Otherwise, there is nothing like that. I have no need on it. So like that, there will be. And then from testing to deployment, the deployment engineers will be taking care of the deployment. After once the deployed on the client end, we will be looking for the maintenance. So who are all the various roles that we will see in various phases? So you can see, leave about all others. So there are number of other people, but DevOps sits in two phases. DevOps sits in two phases. One is testing, the other one is deployment. Testing and deployment. So the testing is very much important before deployment of a particular thing at the client end. After deployment to the client, again the DevOps engineer role is very much important. I can say something like when in this particular model of development, it is a more understandable and an easy way. But the man hours for that particular software until maintenance, the others are kept free. So let us say the requirements were collected by another team and the maintenance is done by another team. So the interaction between the teams are not the same. The interaction between the teams are not the same. So that is why when the interaction is not the same, or not as expected, then what we will see here is there will be lack of cohesion between the teams, and it leads to various other problems. To overcome this, from waterfall model, an agile model is proposed. And in this agile model, an agile model is a spiral model where we will be, all these teams will be working together. A team will be consist of all the people from analyze to define, design, test. Design includes development also, test, and then deploy. So it is a spiral model. Instead of going it from one to the other, it is a continuous development model until you deploy, until the customer is happy. Okay. Instead of a step-by-step procedure, a spiral incremental model is Agile. And when you look at an Agile model will be having a different kind of approach apart from the waterfall model. In Agile model, uh, we call it as a small pod who is responsible for that delivery. There will be a product owner for that small task, and he is responsible for analyzing that, and he will be discussing everything with the test with the team. So there will be a product owner, there will be a designer, developer, there will be a tester, and there will be a DevOps engineer kept together into that pod. And sometimes a DevOps engineer is responsible, he himself will be responsible for testing. Even though there is a tester in the team or not present, he will take care of the testing using some testing tools or automation techniques that we will adopt, and then he will be deploying it. So it depends upon the organization to organization. If it is an existing code, it depends. So most of you are working, we need not to go into those details. And what is this DevOps? So the operations as well as development put together, we call it as DevOps. DevOps is a full life cycle investment. DevOps is a team undertaking. DevOps is one of the better development practices and delivery practices. And DevOps is responsible for continuous delivery. Continuous delivery. Increment 1 to increment n until it reaches the required things. So like that, putting together the development as well as operations, it is called as DevOps. Why DevOps is such popular these days? Because you can see here continuous integration and continuous feedback. So you will be having a plan, build, deploy, operate, integration, and feedback. So these are all the various things that will be having a real-time communication, and you can see here various tools are available for doing this. Various tools are available for doing this. I had mentioned tools there. In build, there are certain tools, and in develop and in planning, there are certain tools. Deployment, operate, everything is having different tools. And apart from this, these tools are, most of these tools are open source and few of them are proprietary too. But however it is left with the organization which tools they will use. But the core work of a DevOps engineer will not change. Wherever he is working, he need to do that particular job, and that particular job will be like this. So like building, planning, integrate, deploy, operate, and take feedback. So again, it is a continuous development process. Delivery icons. Okay. So this is what we are seeing with respect to the and coming to the syllabus. And coming to the syllabus, the learning objectives are like this. Introduction to DevOps. We will go through every theoretical concept to make you understand the need. So this will not take much time. Maybe one class is enough for this. And then virtualization and networking. We'll start with basic Linux commands, understanding you and making you familiar with Linux commands and usage of the Linux environment. Before this, I will teach you how to create a compute engine in GCP. And then you can start practicing your Linux commands on that machine itself. Don't worry that you need to have a separate Linux machine for doing all these things. In GCP, you can select a machine. From that machine, we can start doing that. Okay. And then basic network fundamentals, understanding of basic network fundamentals. What are all the definitions of networking that we need, and web application architecture. So these are how we will be going with the operating system, virtualization, and networking. Yes. Next. From here, we will be starting our own activities like cloud computing, introduction to cloud computing, DevOps, and various types of clouds that what I was discussing, like infrastructure, platform, and software as a service. And then networking concepts of GCP, GCP compute services. The basics of this compute services you will be learning in the very beginning classes, where you need a Linux machine for doing your activities. And then GCP load balancing. So a load balancer is required to distribute the traffic. So whenever there is a failure on one machine, it should not impact the delivery of the things. That is why this is equally important. So load balancing is required here. And then after load balancing, we will go into containers, orchestration services like Kubernetes engine and Google Cloud Storage, serverless services or computing. So these are all the various GCP concepts that we are going to deliver to you, and we will be having a practical session on all these things. And before this, I will introduce you in between somewhere here with the repositories, Git. So I have just segregated them for understanding, but there will be, I can say, covering of syllabus is per the requirement. So something like I will bring few things before a particular concept, because we are not going to teach you a lesson that what we will be doing as per the table of contents. So it is depending on the requirement. So before this, I will be teaching you something like repositories, GitLab or other things before understanding of load balancing and other things. So here you will be learning with the various version control systems for Git as well as GCP, and we will be having a hands-on lab, and then we will be coming to other topics of GCP. And we will be having a hands-on lab for everything. I will give you a small project where you will be working on that project for understanding, and we will be having a continuous interaction during that project. And coming to containerization and orchestrations, we will be going through Docker, Kubernetes, and Ingress. And then for automation of the orchestration and config, we will be using Terraform, Ansible, all these things. So finally, continuous integration and continuous development. Here we will be again using GCP for this, and then these things, Maven and SonarQube, these are not the last things. I will teach you somewhere in between to installation and development of a particular software during these sessions itself. Here itself. There itself they will come. After a computing machine, once the computing machine was successfully deployed for you, I will teach you how to install Maven and running a small programs, maybe using some language. Language is not a restriction for us, just for understanding. Maybe some HTML programs, or maybe some Java programs, or maybe some other code, whatever it is. It is not a big. So, like this syllabus we are going to cover for you, and most of the things I had covered for you in the demo session, and more practical things we will see from tomorrow's class. Well and good. That's all from my side. So I want to hear from you. How did you felt?
I'm okay, Adi. I can able to get the concepts well.
Yeah, thank you, Prasanna.
Yep.
Raju? Okay then. Thank you. That's all for today.
Is just I have a quick question. Like, are we going to take up the classes in the same time?
The timings are left with the organization. So usually this is my time, Prasanna. And
Okay.
so do you have any difficulty with the time?
I really don't have any objections, Adi. I'm good to go.
Yeah, thank you.
Yeah.
So that's all from my time. All other students, you can leave. I will be waiting here for some understanding of the chat, what people have been shared, and then I will leave. We will be leaving. Prasanna, Raju, you can leave.
Okay. Sure. Yeah. Thanks.